Center of gravity of remainders is what we are going to cover in this lesson. Now, what is the remainder? You see, when I have a full paper, like this one is covered, it's now a laminar. But now when I cut out a certain figure or a certain shape, as you see, this one we call it now a remainder. And so, if I have a remainder, now the gymnastics is going to change somehow. How is it going to change? Now, the weight of the whole lamina, we are going now to subtract off the weight of this one we are taking out. So, we want to get the center of gravity, we shall subtract off this weight that we've been able to remove or that has been cut out. So that's the only case we have. Then, the idea is we are going to know where do we take the center of gravity, from either from the vertical and then the horizontal. But what is the gymnastic there is what we are going to see in this lesson. So let's start with a simple thing here. Of course, as you remember, we are going to also use those formula there, these two. Find the center of gravity of the remainder when the figure below, in the figure below, after removing a square PQR. Now they are telling us that this is a square. What does come in your mind when there is a square? I think we know that all sides are equal. So all we need, you know that now this one has been removed, so it's no longer there. So what happens? We get now this, we shall get the weight of the wall before this is removed. Then after, we subtract off the weight of this, then we shall be able to get the weight of the remainder. Then we get the coordinates and so on. Now, we first get the area. So this is, I'm going to call this one the area of the big one. This is A1. Then this one I'm going to call it A2. So my A1 is its length times width, because it's a rectangle, it is going to be 12 times 8, and that's going to be 96 centimeters squared. So now we get the weights. Our weight 1. How do we get the weight? We say to get the weight, you get the area times the weight per unit area. Because we don't know this, that's why we get our W be the weight per unit area. So to get now the weight, we shall get this, the area times the weight per unit area, which we are saying is W with is. Then to get area 2 is a square. So I'll just get, now the question is, what are the dimensions? Now I think that from here up to here is 3 units, and from here up to here is 3 units. But remember, the whole of this from here up to here is 8. So if this is 2 and this is 3, it means that the whole, when we add this and this, is 5. So meaning the balance is going to be 3. So this would be, now if this is 3, it means that this one is also 3. So our S squared, but it's that our S is going to be equal to 8 minus 5, okay, let me say 3 plus 2. So our S is going to be 3, and so our area 2 is going to be 9 centimeters squared, and so our weight 2 is going to be 9W, as simple as that. Now, from there, now we need to get the weight of now the remainder after cutting out this. So we need now to get the weight. So we say weight. Now instead of getting total, here we are getting the weight of remainder. Remainder. It's going to be, now you get the weight for the whole, which is 96 W. Then minus the weight of the thing which will be of the cut. In there. So see, this one is going to give us, when we get, this is going to be 90, this is going to be 83, 87, W. As simple as that. So that is the case. Yeah, that is the case we are having there. So now the weight of the remainder is there. Now, if we have the weight of the remainder, I need to know where is it acting. So now, we start by getting this idea here. So now it's time to redraw. After I redraw the whole shape here, I think now you can see if I redraw that, It means that now, remember the center of gravity for the remainder is going to act, of course, in the middle. The center of gravity of the remainder is going to act in the middle. So I'm going to be having this one here as my D. For the one, B1. Of course, the other that's the dimensions are. This is 12 centimeters. And this is going to be 8 centimeters. Of course, for the whole of this, the center of gravity will be active there in the middle. Now, this is the middle of this remainder. Now, from here up to here, so that this is 6. And then, from here up to here, this is 8. So the half of that is 4. This is what I summarized here. For a square, we get the sides divided by 2. For a rectangle, we get the length by 2. Then that will be by 2. That's where we'll be having the center of gravity. Now, if you come to the remainder, our remainder, you have to be a bit careful. So this is our square here. Of course, it's also going to be having its own center of gravity if it was there. So our D2 is going to be there. D2. Now, how do we find the D2? Remember, first of all, from here, because remember, this is a 3. So our square, okay, let me put it here. Our square, this square here, it has this as 3 centimeters and this as 3 centimeters. What does it mean? It means that now, to get this here, we are going to get our D. Remember the center of gravity for only this. Now, the center of gravity for this, it will be this divided by 2. But now, we are going to take our center of gravity from the side Z, A, B, C, D. So that's where we are taking our center of gravity from now. From AD to this, that's why you have 6. Then from AB to this, that's why you have 4. Now, from here, remember I told us that this one, this distance here, just this one, is 1 centimeter. From there up there, so this is 1 centimeter. Meaning to get now the center of gravity from AB, I'm going to get this one plus from here up to here. Remember this one is in the middle, so from here up to here, there is 3. Meaning from here up to the middle, it's going to be 1.5. So then I add the 1.5 and this, I will get 2.5, comma. What is the distance? From here up to here, there are 3 units. And then the 3 units, from here up here, there are 3 also. So when I get a half of this, then I'll be getting 1.5. So 1.5. Now from AB, so from AB up to here, I'll be getting the 3 then plus the 1.5, which will give me 4.5, and that will be the center, or as simple as that. So, center of gravity using AB and AD as axes, as simple as that. Now what's going to happen? To get the center of gravity, of course it's going to be x bar, y bar equaling 2. Now our first weight. Now, this weight here of the remainder, the weight of the remainder is going to act here. So here you're going to be having our weight 1. And here you're going to be having our weight 2 acting there. Weight 2. Remember this one is outside. So that's why we are not going out some, but we are going to get the difference of this minus this, because this is out. So now our weight 1, we are going to get weight 1 and its coordinates. Then this time we are going to say minus weight 2 and its coordinates over W1 minus W2, as simple as that. So from here, our x bar, y bar is going to be, our first weight is 96 W divided by mean times, now this one is going to be 6, 4, then minus W2, which is 9, W, where is it acting? From AB, it is 4.5, and then from AD, it's 2.5. So 2.5, then 4.5. The idea is you need to know this one, you first get the center of this, then after you add these distances from here up to here. When you do that, the rest are going to be very, very okay. The all over, the difference of this we've seen is we are getting 87 W. So after that, then we can empty come and get our X bar, Y bar. So let me put and okay, the upper part is giving me 5, 3, 4, 8, 5. Then the down part is 3, 4, 3.5. W, the all over 87 W. And so from here, my X bar, Y bar, we divide. We get this divided by that. 87. So here I'm going to give it 4 decimal places, 3095. Then I divide the other one. Let me give it 6.36. That's where my center of gravity will act. Therefore, center of gravity of remainder is at 6.36, 3.95 using AB and AB as axis. Okay, maybe if I'm rectify that for the center of the square, you see this one is going to be from there, this one is going to be up to there, this is going to be 1.5, and also this one from there up there, it will be 1.5. But this 1.5, we add on these ones from here, and also these ones from there. That's how we see we are getting the 2.5. Therefore, here we added 1.5, then plus 1, which gave us 2.5. Then on this 1.5 plus 3, that's how we are able to get the 4.5. So our give 2, that's why our give 2 was at 2.5, 4.5. As simple as that. So that's it. I wish you well. Don't always forget to subtract the 2. You subtract off. Even if they are 3, you subtract off those things you've removed.